हरिः कन्ना।
Now let's stack together different ND arrays. Let's stack different ND arrays together. Okay. So several arrays can be stacked together along different axes. Along different axes. That's very important. For that, what we will do is we will create two new arrays. Okay. So first, this is stacking together different arrays or arrays stacking. Okay, so let me create array 1a is equals to np dot, I'll go with the floor, and 10 times rg dot random, and I want 2 by 2 float. It's a 2 comma 2, and execute. A is ready, and similarly I want a b is equals to np flow 10 times rg random float 2 comma 2. So b, it's 6 point, 8 point, and these are all floating point numbers only. So now how to stack it? The first method I'm gonna look into is stacking along different axes. So let's do it. The first method. So the first method we have is np.vstack. So the vertical stack, the v stack. So first let's look into the v stack, and second one we have head stack. So first we do the v stack. So we got np dot vstack. You see that vstack, and in vstack I'm gonna give a tuple of arrays, and this is how they got stacked up. So a and a b. So let me print this. Let me put it into vstack variable. Sorry. Let me put it into vstack variable. So print vstack, and here is that you got a single. So let me see the shape of it, and let me also see the size of it. Let me also see the dim and dim of it. You see that it's a 4 by 4 rows, 2 column, and then 2 dimensions or 2 axes, and it's a clear cut a matrix. Okay, so these two got stacked up. The first matrix A, the first array A has been stacked up on the B. So now the second one, it's a V stack is done. Then we'll look into the H stack. So H stack, H stack is similar way, H stack, and then a tuple of arrays you just want to stack up, and this is how they got stack up. They got stack up on horizontally along the horizontal axis. You see that? That's what we said. That's what our first method. The first method is to stack them together along different axes. One is along vertical axis, second one is along horizontal axis, and see, here is the response. So I'll just put it into the variable. So I'll say head stack and execute it. So let me call it head stack down here. Okay, let me close. Okay, it's not responding. Let's wait for a few seconds until it responds back. Yeah, it's done. So now let me get into the print. Hit stack. Yeah, then let me see. Hit stack shape. It's 2 rows and 4 columns, and the stacking has taken place in horizontal axis, along the horizontal axis. Let's move ahead. The second method that we have for the stacking here. So the second way is the function column stack. The function column stack stacks 1D arrays as columns into a 2D array. So it's equivalent to head stack only for 2D arrays. So this is what we are going to do now. This is called as column stack. Thus is stacking 1D array with the 2D array. So for that, let me import a new module from NumPy library. So from NumPy, and what I want to import, I want to import a special module called new axis. Okay, I have imported it, no issue while importing it. So now what I'm gonna do is I'm gonna use that column stack. So np, and it's column stack. You see that now it's visible. So column stack, and I just want to stack a comma b, 2 arrays. So I have given it as a tuple to that, and so let me execute. So these with 2D arrays, the column stack between the 2D arrays, no issue at all. So now what I'm gonna do is I'm gonna create and one more array, an array 1D. So np dot array, and obviously I'll give a list inside that. So I'll give 3.4 and 2.5. Clear? So this is my 1D array a dot shape or ndim 1D. Clear? Then let me create one more array. It's a b. Similar way, np dot array, and a sequence inside that. It's a 4.4 and 9.7, and execute it, and b, it's array 4.3. Just wanna print it. If you wanna print it, just you can print it, and here is that 4.3 and 9.4. Clear? So now what we're gonna do is we are going to stack up these horizontally. It's pretty simple, it's not a big deal. So I'll type hit stack 1D, hit stack 1D, then np dot hit stack, and I have a tuple inside that. So I'll just mention the tuple a comma b. So hit stack 1D and execute it, and here it is 3.4, 2.4, 4.3, 9.4. It's pretty simple. Okay, so now what I'm gonna do is I just wanna take a slice out of it. So a of colon, and I'll say new axis, and here is that response. So it views, when you give new axis in this way, it view a array as a 2D column vector. You see that? That's what had happened here. It's been viewed as a 2D column vector. So that's how we use it. So now what I'm gonna do here is, so I will use np. So now let me call a. So this remains same like this, but when you use a new axis, it will be converted into a 2D column vector. If you just want to check the end dimensions, ndim, and here is that it's a 2D, absolutely 2D, no issue at all. So That's what I'm talking about. So what I'm gonna do here is I will save this into a variable. So I will name it as a2d. Done. And here remains a, but a2d is the one more array I have, and here it is. So now let's use column stack. So how do we do that? We have uh, two arrays. So I'm gonna convert the two arrays into 2D, and I will stack up. I will stack them up. So np dot column stack. So access, new access is the one that module has been imported from the NumPy specially. So and inside that I'm gonna put two arguments. So the first argument is a of colon and new access. It's literally what we are doing. We are just converting it into 2D. A 1D is being converted into the 2D. And the second argument is the second array. So that's B, and that also will be converted. So colon and then space new axis. And let me execute it and see. You got a new error, which is new array, which is of 2D. If you have a doubt, let me put it into a variable. So I'm gonna say a b 2D. So a b 2D. This is what. So now I'm gonna check the endim of this endim, and here is that it's a 2D. So this is how you convert 1D into 2D, and you stack them up using this column stack. Clear? So next, the third one. On the other hand, the function row stack. So we have seen the column stack. Similarly, we have a function called a row stack is equivalent to vstack for any input arrays. In fact, a row stack is an alias for vstack. Let's do one small exercise for this also. I'm gonna say row stack. I'll put a 4 or 3 row stack. Clear? Yeah. So let me take the np and column stack. We have seen it's similar. Is it similar to the hit stack? Who knows? Let's check it. np is same as np hit stack. False, and not at all. They are not same. Let's check it for the row stack. What will be the result? Row stack at the bottom is np. I think it's a v stack, and it's true. So row stack is similar to the v stack. That's what it's been proved here. So in general, for arrays with more than 2 dimensions, hit stack stacks along their second axis, v stack stacks along their first axis, and concatenate allows for an optional arguments giving the number of the axis along which the concatenation should happen. So one more, in for example, in complex cases, we use r underscore and c underscore are also useful for creating arrays by stacking numbers along one axis. They allow the use of range literals. Let's look into that. So this time I'm gonna say for it's r underscore and c underscore. Correct? Yep. So 6, and let me take the first example, r underscore, and then I'm gonna give an item inside that. Okay, 1 through 4 for the rows, and after that 0, and then 4 is the stepper. And here is that. You got it? 1, 2, 4. Of course, 4 is excluded. That's 1, comma 2, comma 3, and then 0, and then 4 is one more. So when used with arrays as argument, R underscore and C underscore are similar to V stack and its stack in their default behavior, but allow for an optional argument giving the number of the axes along which to concatenate. So I would urge you to explore more about these concepts. Okay. So head stack, V stack, column stack, concatenate, C underscore, and R underscore.